Hello guys, welcome back. Could everybody comment if they're here, just so I know who we got, because today's the first day we're broadcasting to you guys at home. Right, so yeah, today we're going to be looking at histograms. There's a few different aspects to histograms that we need to be looking at. Hello, Nula. So yeah, first, hello Lucy, Callum, Tristan, everybody's getting here now. Good. Right, so histograms, as you hopefully remember from GCSE. There's a nice little histogram. On the y-axis we have frequency density. And on the x-axis we have our data. Let's just call it x. And there's a few kind of key points about this. So the bars must touch. If the bars don't touch, then it's a bar chart, not a histogram. So make sure your bars. This one probably wouldn't get away with that actually. Let's fix that so it looks proper. Yeah, that'll do. And yeah, so bars don't touch, and histograms are only for continuous data. Reason being, we need to have these continuous x. The bars can't touch because these margins are continuous. So you get one bar going into the next bar. So this might be, I don't know, 4.9 to 5. This might be 5 to 5.1, 5.2. This could be 5.8. They don't have to have evenly spread bases. You probably should draw it together. So I call that 5.4, 5.6, and then let's make this last one a little bit longer, up to 6. Cool. So you don't need to have evenly spread bars, but we kind of account for that with our frequency density, as you guys will see in a bit. And there's a couple important equations to remember with histograms. The first one being that frequency density I've drawn that a bit big. Frequency density equals frequency over class width. Like that. There we go. So we need to remember that one. One way I always think about remembering this is if you've studied physics before, or even if you know the word density. Density is a measure of the amount of mass or stuff you have per unit of volume. So if we kind of try and apply that to the histogram, it's a frequency density. So therefore it's the amount of frequency you have per length. Frequency per class width. So try and think about it in terms of what density actually means. And then it's kind of easy to remember this equation. So frequency density, frequency divided by class width. All right, so because you guys have done some histograms before, I thought let's just jump in and try a question and see how you guys get on with it. So I've stolen this one from the textbook. I'm just going to make this graph a little bit bigger. That will do nicely. So I'd like you guys to have a go at filling in this histogram. First, you're going to need to fill in the gaps in this table and then try and complete what's going on in the actual histogram. So give it a go. If you guys could comment, let's have, if in your comments you want to put whatever number is missing from here Yeah, oh, I've got some green screen clippage today. I'll fix that in a second. Yeah, if you could write in whatever number's missing here, here, and here, followed by whatever you think the frequency density should be for this bar. So comment for me those four numbers, and I'll give you guys 3 minutes to give that go and see what you can remember about histograms. Just to kind of wake your brains up this early in the morning. Cool. Cheers, guys. Get started. How are we all getting on? Anybody got any answers yet? So please comment as soon as you've calculated anything. What should those frequencies be? And what should that frequency density be? Lucy's first in, so we got 10, 7, 6, and frequency 5. Let's just have a quick look. 10, 7, and 6. Ooh, some different answers there. George, Lucy, slightly different. Billy, 10, 7, 6, and 4. Interesting. See, 4 more seconds, and that is time. Cool. All right. Yeah, a few sets of answers there. I actually forgot to write down half these, so I only know a few of them myself. So let's have a look through. And remember, the equation we need to use is frequency density FD equals F over CW. So class width and frequency density there, little condensed version of the equation. So for our first bar 20 to 30, let's have a look. So I would say our frequency density there goes up to, what's that, 1, 2, 3, 4, 5, 0.2. So we got 0.2 equals frequency, which is 4 divided. Oh, this one's been done for us. Let's skip that. Okay, 20 to 30. There we go. So frequency density equals 1 equals our frequency, which is the unknown f over class width, and I would say our class width there is 10. So if I times up by 10, we're going to get 10 for our first frequency, which I think you all agreed with me on. Yes, everyone got 10. Good job, guys. Second one, let's have a look at 40 to 50 then. So 40 to 50, and this is where it gets a bit harder to read. So this probably is why some of you guys got different answers. So our frequency density is going to be, what do you reckon, to 0.2, 0.4, 0.6, 0.7, I would say for that one. E equals F over a width is 10 again, so times it up, get F equals 7, which again, everybody seems to agree with me. Good. Okay. And the last one, 50 to 70, if you have a look, 0.2, I reckon that's 0.3 there, is F over 20. So 20 times 0.3 is going to give me, and 6. So I make it 10, 7, and 6. Let's see. So I agree with Lucy so far, Billy so far, George so far. Actually, all of you got that. That's pretty good. Well done, guys. Okay, so looking at the unknown bar there, that's the last bit we need to do. So this time we're trying to find out what the frequency density needs to be. So FD, remember it's 30 to 40, so that's this bar. Oh, we're going to need to draw 2 bars because that's not 1 bar. Okay, let's forget that. So if we look at top bar first, FD equals our frequency 15 divided by our width, which is 5. So we should get a frequency density of 3 for this first bar, which is going to go from 30 to 35. So not the easiest thing ever to draw, especially on a iPad. And I need to go up to 3 for this one. Cool, good. Which I think a few of you guys have got. Yeah, good. And for the second one, we got 35 to 40. So again, FD is going to be our frequency 25 divided by a width of 5. So we need to go, is that right? Width of 5, frequency 25. Looks like we need to go up to 5, which they've not really left us much room for on the sketch, but that's okay. So all the way up to the top and back down again. So I make those my answers. So could you guys check those off? Make sure you're happy with those. I think Lucy was the only one to firstly just spot that this is 2 categories. We need to treat it as 2 separate things. I can't get rid of these green screen bits. I have tried. Yeah, it's annoying, but oh well. There we go. Cool. Okay, let's move on then. Has anyone got any questions about this first of all? I'll wait 5 seconds, see if anyone has any bits they want to ask me. Nope, cool. Alright, let's move on. So, next up, there are 2, that's one kind of key part of histograms is being able to draw your own histograms. The next bit you need to know is 2 very, very key points. And students often forget these. So if you guys can write these down and make sure you don't forget them. On a histogram, the area of each bar represents frequency. It's not equal. Area does not equal frequency. Area represents frequency. So we could also say the frequency is a constant of proportion, k, times the area. Cool. So basically, the area is a factor of the frequency. And this should kind of be ringing bells for when we did vectors. And we had with vectors, if 2 things are parallel, if one kind of was the other, it's a different kind of scalar. Here we got scalar k. F is a multiple of, or a factor of the area. So I always remember just the bullet point. Area represents frequency, but you might have to work out a kind of like a key, a scale factor, how you're going to find area from your frequency, or how you're going to find frequency from your area. If you look at the histogram, see what its area is, you should be able to get from that your overall frequency. And the other key point is width or bar width represents class width. In the same kind of way, so I can say that my width or class width equals k times the bar width. So if your width on your histogram is 5 centimeters, that won't always mean you have a class width of 5. A width of 5 centimeters could represent a class width of 10, 20, any kind of scale factor, but they're not always going to be one-to-one. So we need to work out what these scale factors are. You can work it out as k, or you can just think about it and write down scale factor equals this, and then remember to use that when you calculate different sizes of your bars. So I'm going to put here as well, not always equal. By equal, I mean directly proportional. So in other words, k doesn't always equal 1. It rarely does. Sometimes it does, rarely does k equal 1. I've forgotten the S in always there. I think I wrote with my hand instead. So yeah, not always equal, directly proportional. Okay, so we're going to try this. We're going to put this into practice with this question. So, from the large data set, we've got some data here for Leeming in May of 2015, summarized in the table. Histogram was drawn. The 8 to 10 group was represented by a bar of width 1 and height 8. Use that information to find the width and height of the bar representing the 11 to 12 group. So I've written the bits up here again. Area represents frequency and width represents class width. You can just about see the frequency there. The only two bars we need though, the 8 to 10 group and the 11 to 12 group. So here's our 8 to 10 group. And here's our 11 to 12 group. So I'm going to give you guys, again, I think 2 minutes this time, or maybe 3 minutes, just to have a look at this and see what you can do on your own. We will be going through this in a second, but I just want to see if any of you can figure it out based on those proportions. That's the key bit. Find the area that represents your frequency, and the width of your histogram should represent your class width from your table. Cool, give it a go. Comment your answers again if you can find the width and the height of that bar. Well done, George. That is correct. So whatever method you use was good. Harry, you're slightly out. I think you scaled yours up by the looks of it. I will go through it in a sec. Cool. All right. So well done, Harry, and a few of you actually, and Louis, and Billy as well, and Lucy. Cool. Awesome. Well done, guys. Um. Yeah. So it's just using those sentences. Ooh, that's never going to stop. It's just using those two expressions here. That's all we need to think about is that they represent each other. So we're going to do the 8 to 10 bar first. So make sure you label it so you don't get mixed up in your workings. Callum, well done as well. Good answers coming in now. So the width for my 8 to 10 bar is 1. Let's start with width. And my area is, well, to work out the area, I need to times my width and my height together. So my area is 8. And we are talking here about a frequency of 8, or class width for 2, CW equals 2, and frequency equals 8. Okay, so straight away from this I can see, well, my class width is double my actual width, or I could say my width is half of my class width. So width equals half of class width. And my area is exactly directly equal to my frequency. The thing I said rarely happened is happened in this question, but that's fine. So area equals frequency. Cool. So we're going to use these two statements at the bottom to try and find the histogram of the bar width for the red group. Cool. Everyone seems to be getting this right. So well done, everyone. All right. The other bar then, 11 to 12. Let's write down what we know about it. So I know my class width is 1, and I know my frequency is 7. So remember, our width should be half of our class width. So if my class width is 1, my width is 0.5 centimeters. And that's part of my final answer. We just need to work out what the height needs to be. So the area should equal the frequency, so the area should be 7. So if the width is a half, and the area is 7, the height needs to be 14, because 14 times a half is 7. So my height is 14 centimeters. And that's it, then we're done. Right, if you've got any questions about that, please ask, guys. But it's just the idea, work out the stuff we know for this bar, find the conversion factors. You don't have to do it with algebra. We just said class width is half class width, area is frequency, and apply those scale factors to the bar you want. So I always think this is like the key to understanding these factors here. Cool. Let's see if you guys have any questions. Nope. Cool. Everyone seems happy. Let's move on. Right, so I'm going to give you guys another kind of question to do. So we're just kind of summarizing all the bits of histograms, and we're going to put it all together at the end. But the next bit we need to be able to do is to read histograms. So hopefully you guys can see that. I might be able to make it a little bit bigger on the screen there. Okay, I'll read this to you, and then you guys are going to give this one a go. I need to sort out this corner. It's up here, isn't it? It gives. Maybe that's better. Okay, so did as ratios. Yeah, ratios is absolutely fine, Louis. Nothing wrong with that. That's what we're doing. Basically, we did ratios, but kind of either algebra if you're finding the scale factor, or we kind of did it in words. But yeah, ratios totally fine. Okay, so this question is always about reading and understanding histograms. So some students take part in an obstacle race. The time it took each student to complete the race was noted. The results are shown here in the histogram. Okay, so we've got the time it took them to do the race down at the bottom here, and we've got the frequency density on this side here. So how to think about each of these? Yeah, so should be totally doable. Be careful with your calculations. Remember, this one's all about frequency density is frequency divided by class width. So if you guys could try and comment your answer to part A as a sentence, followed by 3 numbers for these ones. It's a bit longer, this question. I think let's have 5 minutes and we'll see how you guys do. Again, most of this should be GCSE revision, but yeah, comment your answers and we'll see how you get on. Sorry guys, just had to answer an email there. Cool. So Tom's got 0.5 and 14. I haven't actually done this one, so let's give it a go together. Cool. Right, let's just shrink this back to the size as usual. Cool. Right. So, give a reason to justify the use of a histogram to represent this data. Thank you. Sorry, guys. Yeah. So, yeah, give a reason to justify the use of histogram as data. Did anybody get that? I can't see any comments giving me a reason for that one. So, why is this good data to use in a histogram? It's because it's continuous data. So we can say time is a continuous variable. So that's pi. Yeah, good, Ollie. Nice. And George, well done, guys. You did get that. Good. Number of students who took between 60 and 70 seconds, so that's this one here, is 90. So that area represents 90 students. So 90 equals area of, let's work out the area. So we got a width of 10, height of 6. So 90 equals an area of 60. So in other words, an area of 1 equals 2/3 of a student, I think. It's that 3/2, isn't it? Yeah, 3/2. So there's my key. Area of 1 on this graph represents 3/2 students, so 1.5 students. Okay, so we want to find the number of students who took between 40 and 60 seconds. So if I look at my area for this one, we've got 5 times 20, so we've got an area there of 100. So that's an area of 100, which is going to be a frequency of 150. So all I'm using there, I've worked out based on this bar that an area of 60 represents 90 students. So I know an area of 1 is going to represent 3/2 students. Apply that up here, area of 100 times it by 3/2, and we get 150 students. So this bar is 150 students. Cool. Which Jake has got correct. Good. The next bar then. So we've got a width of 10. Actually, have we done this one? No, they told us this one already. This one's 90. Okay, less than 80. So I need to work up this bar here as well. So for this one, we got a width of 10 and a height. It's going to warrant further inspection, I think, this one. So width of 10. So my height is going to be, well, if that's 9. Sorry guys, this must have been a nightmare for you to do on your screens. 9 there, so we got 8 points. Is that halfway between the two? That is tough actually. So 9 would be here. So we've got 1, 2, 2.5. So 2.5 there. I reckon that's kind of half there. Let's say frequency density is 8.5 would be bang in the middle. So there. I reckon that's something like 8.6. I think I'd have to check the textbook to work out what they're actually saying on that scale. So yeah, let's go for 8.6. So I reckon my area is 86. I hope this divides actually. We'll see. Um, 86. So if I times that by 1.5, we get 129. So yeah, it might be 129. I think on that one, they would let you have plus or minus 5 in your answers. So 80 seconds or less, add all those numbers together. So 150 plus 129 plus 90. I make it to be 369 students for part C. What do you guys go for? Oh, Jake got 369 as well. Good. Tristan 370. Yeah, you'd be allowed that. That's fine. Scott 124. Think that's off, but maybe you only worked out this bar and forgot to add all the others together. So taking a look at that one. Harry, did you comment, Harry? 369. Yeah, good. We're pretty good at reading graphs then between us, I think. Let's look at the last one then. Calculate total number of students who took part in the race. Okay, it seems like quite a lot of effort for one bit of a question, but let's do it. So we got a width of 85. Let me just get rid of what we've done so far. Oops. Need a bit more space. So we got for the 80 to 85 bar, we got width of 5 and a height of 14. So that gives me an area of 70. So 70 times 1.5 gives me 105 students. So 105. Next bar, let's do in green. So we got a width of 5 again and a height of 12, which is going to give me 60, which is going to be 90 students. And the last bar has a width of 30 and a height of 3. So that's an area of 90, which is 135 students. So add them all together. And I make it 699 students. So what have you guys got? Jake 699, I agree. Elliot 699, I agree. Cool. Looks pretty good to me, guys. Oh, excellent. Right, has anyone got any questions? Because these, yeah, they can be tricky. I'm just gonna move everything down just so you can see it all again. Yeah, there we go. Cool. Anyone got any questions? Tristan 700, yeah, fine, you'd be allowed that. There's nothing wrong with that answer at all. George, yeah, good job. I really want to sort this green screen out. It's rather annoying. No, it's not gonna do it. Oh. Cool, good. All right, moving on then. What is next? So page 6. Okay, I want you guys to try this one now. So again, we're looking to try and find the boundaries and then try and find the width and the height of this bar. So a bit more practice finding the area, height, frequency, class width relationship there. So here we're talking, I think, 5 marks. So again, let's put 5 minutes on the timer. Cool. All right, give that a go. Cool. Right, welcome back. So a few answers there. It looks like you guys are all in agreement with each other. Yeah, Billy corrected yourself there. Good. Okay, let's go through this one then. So, yeah, same idea again then. So write down the class boundaries for 13 to 14 class. Hopefully you all got this. This is the true class boundaries bit we were talking about last week. So the class boundaries there, 12.5 to 14.5. Good, good, good. And yeah, everyone in the comments there does seem to have that correct. Well done, guys. Histograms drawn, bar representing 13 to 14. So we've got 13 to 14 has a width of 4. There's no point writing the height. All we care about is the area. So I'm going to times those two together and write down my area is 24 centimeters as per units in. And we know that corresponds to a width of 24 corresponds to a class width of 2. And the area of 24 represents, again, an area. Done some bad choices choosing you as the exact same areas. They're not always proportional, I swear, but in these two questions they have been. Oh, well. Okay, so we want to try and find the 15 to 17 class. So the 15 to 17 class has a class width of what's going to be 14.5 to 17.5, so class width equals 3. And we've got a frequency of 18. So, right, class width of, in the first case, a class width of 2 was a width of 4. So we doubled it. 2 times 2, 4. So we're going to times this by 2 to get a width of 6. Which, looking at the chat, you guys all managed to get. Brilliant. And our areas are proportional, directly proportional, so our frequency and our area are going to be directly proportional, so area equals 18. So therefore, if we do 18 divided by 6, we get a height of 3 centimeters. Cool. Which again, everyone who posted in the chat got it correct. Brilliant, guys. Cool. Right. Hopefully no questions there. Thank you. I love the hint. Remember, the area is proportional to frequency. They gave it away with that one. Yeah. So these come up quite often. If you get a histogram question, there'll usually be one of these on there as well. Okay. Next up then. So we're going to be talking about frequency polygons. So I've got a histogram here and a frequency polygon. Basically, all we need to do is join up the middle of the tops of each of these bars. So I'm going to put some dots on these just so you guys can see what's going on. So put some dots on the middle tops and let me join them up. That's not too bad. Maybe this line could be a little bit better. Lovely. Cool. So join the middle of the tops of each bar. Okay, that's it though. That is the final polygon. You don't join it up with the axis. So don't join with the axis. Cool. And yeah, kind of useful. You can kind of see what the overall proportion is, where the frequencies are roughly, because it takes into account the width and the height. So yeah, it gives you a nice chart of where the most frequent parts of your Oh, God, I'm tired this morning. Where the most frequent parts of your data lie. Good. That's pretty much it for histograms. You've been able to draw them, you've worked out your own widths and frequencies, and you've read them to try and find out what frequencies relate to. So I think for the rest of today, we're just going to do some practice. It's gone a lot faster than I had planned, so I might have to come up with some more questions on the fly, but good so far. Right, so you guys are going to try this. This one's a bit more of a big question. We did do part A of this earlier on, so part A there is the same as this one we did earlier. So I'm going to cross that one out. There's no point doing the same question twice. Actually, let's tweak it. Let's find the width and height of the bar representing the, what should we go for? Let's go for the 15 to 16 group. Cool, let's try that instead. It'll make things slightly harder. So this question is worth overall 9 marks. Yeah, let's give it a go. So I'd like you guys to try this. I'll give you 10 minutes for it. So I'm going to go a bit quiet. I need to do it as well because I'm practice this one. But yeah, see how you get on. So this is not only is it histogram stuff at the beginning, but it's recapping the standard deviation, interpolation that we did the other day, and also estimating how many days were more than that. So quite a lot of interpolation in there. Give it a go. And see how you get on because we didn't really practice this stuff much the other day. So 10 minutes starting from now. See how you do. And don't forget, comment your answers when you've finished. need to use the midpoints there. Cool. I'm gonna give you a little bit longer because part D isn't very easy. Part D, as a hint, is you're gonna use standard. You're gonna use linear interpolation, but instead of knowing the frequency and finding the value, you now know the value when you're trying to find the frequency. So, let's say 3 more minutes, guys, just to try and finish that one off. A couple answers there. Just to give Billy some feedback, I agree with part A, Billy. I agree with part B. I do maybe agree with part C. That's rounded, I'm hoping. Part D, I don't agree with. So see if you can have another look at part D. Yeah, 3 more minutes on the clock then. Let's see if you guys can get part D done. So the hint is linear interpolation, but it's the other way around to what you're normally expecting. If you need any help or hints, please comment and I will reply giving you some hints. Okay, a few questions there then. So linear relation, so that's Lucas, I think. What values to use? Let's go through it now anyway. That bit was quite tricky. So let's see how we do. Okay, so width and height of the bar representing 15 to 16. I might just shrink this a bit because gonna need to write. So that's the one I changed. Okay, so if you remember from earlier, we had our 4 to, let's do it up here, 4 to 8 bar. Sorry, 8 to 10. So the 8 to 10 group represented by a bar of 1, so width is 1, and our area would be 8. And that corresponded to a frequency of 8 and a class width of 2. So for our 15 to 16, we've got a frequency of 1 and a class width of 1. So my area needs to be 1 and my class width needs to be half, sorry, my width needs to be half of my class width. So my width is 0.5. Therefore my height needs to be 2 to make that area up to 1. So, like Billy said there, I agree with your answer. Well done, Billy. Okay, part B then. Use your calculator to estimate the mean and standard deviation of temperatures. Which is nice, them telling you to use your calculator. They won't always do that. Sometimes they'll give you some of the bits you need. So I'm going to do this on the graphical calculator. So if I bring that up now. Cool, alright, here's my results. Let's type it in again so you guys can see what I did. So I've found the midpoint of our classes. Now, before you do that, you need to check, does it use true class boundaries? And I can see by looking at this, 4 to 8, 8 to 8, 10 to 10, already there's no gaps. So because there's no gaps, it's already using true class boundaries, so we're good. Right, so in list 1, I'm going to put my midpoints. So I found the average of 4 and 8, which is 6, the average of 8 and 10, the average of 10, 11, 11 and 12, 12 and 15, and 15 and 16. And I put the frequencies in. I then told the calculator that my frequency was in list 2. Don't forget to check that. And then I've gone to one variable calculation. So we come up with a mean of 10.4. And a standard deviation, sigma x, of 2.4. Nice and straightforward. If anybody does want me to go through this on the class whiz, comment it now, and I'll go through that at the end of the question. But for now, that's calculated time done. So, question C. So we're starting on our interpolation. So let's do C over here. So we're trying to find an estimate for the lower quartile. So if we write the circles out, we've got Q1, these two. So remember, the first we need to do, if we're finding a lower quartile, we need to do n over 4. And also, probably need to fill in a cumulative frequency. So let's do that up here. So in my table, we get 4, 12, 18, 25, 30, 31. Which makes sense because we're talking about the number of days in May. Jake, I also don't agree with your part D answer. So pay attention to that one again. Okay, so n over 4. So if I do n over 4, that'll be 31 over 4, which gives me 7.75. So that's the value I need to write in the bottom bit here. And the other circles, if you guys remember, are to do with on the top, we have the class boundaries, and on the bottom, we have the frequency up to each of those boundaries. So where is my lower quartile going to be? So 7.75, so that says to me it's in the 8 to 10 class. So my lower boundary, the quartile could be as 8. The upper boundary, it could be is 12. And my frequencies are going to be 4 for the first one, and, sorry, that's a mistake, that should be a 10 there. And then a 12 on the bottom. So I get to this, I'm just going to get rid of my n over 4 there. Cool. So remember, we're trying to find the ratio that Q1 is between these values. So we come up with the equation Q1 take 8 divided by 10 take 8 is 7.75 take 4 over 12 take 4. Cool. So if I type all that into a calculator, we end up with Q1 equals 8.94. If you wanted to round that to 9, you could say, yeah, Q1 is about 9. Cool, which I believe is what you guys got. Hopefully you didn't do that on the calculator, because you can't. I have a sneaking suspicion that some of you did that on the calculator. If you did it on the calculator, you would get no marks. You can't use the calculator for estimating median, quartiles, percentiles for continuous data. So calculator is great for discrete data, but you can't use a calculator for anything other than mean and standard deviation for continuous data like this. So yeah, Billy and Jake, if you guys did use a calculator, you would get 0 marks there. You have to use this interpolation method. It even says it, use linear interpolation. So be careful with that. Okay, yeah, so I think really 8.94 is the better answer. I'm going to get rid of 9. I think we should have 8.94. You could say rounds to 9 afterwards, but we need to justify it by at least having this bit written somewhere. Okay, last bit then, and this bit is quite difficult. So I will clear some space at the top. So this bit says, estimate the number of days in May on which the temperature was higher than the mean plus 1 standard deviation. Okay, so first of all, let's find the mean plus 1 standard deviation, which will be x bar plus sigma, which should be 12.8. So we're trying to find the number of days where the temperature was higher than 12.8. So let's just write temp there so we don't forget what that 12.8 actually refers to. So if you look, when we did interpolation just now, we had all of our frequencies on top and all of our values, all of our temperatures on the bottom. Remember, we found the lower quartile of the temperature. Sorry, I've got that backwards. Frequencies on the bottom and all our temperatures on the top. And we found the lower quartile of the temperatures was 8.94 degrees. So all the stuff on the top in this one was our temperatures. So we're going to put 12.8 on the top as a temperature. And we're trying to find the frequency that corresponds to a value of 12.8. So it's like this, but backwards. We're doing it the other way around. Okay, so where is 12.8 on a graph? So if we look at our table, 12.8 degrees is bang in the middle here, 12 and 15. So in this boundary, we know that 12 is our lower and 15 is our upper. And then we can put in the frequencies that we know. So we know the cumulative frequency up to 12 is 25 and up to 15 is 30. So we're trying to find in this class how many days are after, or how many days are before 12.8 degrees. So we want to find where in this frequency of 5 is our 12.5 days. Okay, so we're just going to use interpolation again. Now we've got it set up, it's the same thing. So 12.8 take 12 divided by 15 take 12 equals f take 25 divided by 30 take 25. And if you solve that, you get 26.33. So that tells me there are 26.33 days when the temperature was below, and it tells me that there are however many days at the end where temperature is above the mean plus 1 standard deviation. So if I do 31 take 26.3, I get exactly 4.7. As how many days are left? So 4.7 days of the month, the temperature was greater than, what was it? 12.8. Okay, please ask questions if you guys need, because I don't think many of you got to that bit. So anybody stuck? No? I'm going to assume no, move on. If anyone does have questions, just type and I will answer those shortly. Alright, I've got 2 more questions to do. We've got 10 minutes. I don't know if it's going to happen, but we've got for everything I want to do today, so this is just practice. So more finding heights and widths for this one, which we've done a bit of already. What's this one about? Ooh, both good questions. Let's do this one, and then we'll set the other one to do for Wednesday, and then we'll start with the other one on Wednesday as a kind of video starter. So if you guys could try this one, it's 5 marks. I'm going to give you 4 minutes for it because I'm feeling mean now. We're at the end of the video. So yeah, 5 marks, 4 minutes. Starting from now, could you guys try this one? Anyone need any help? Do comment if you do. Cool. Right. Hopefully you guys had enough time to get somewhere with that one. Let's quickly go through this, and that'll bring today's lecture to an end. So, okay, 0 to 1 kilometers. So that's this one. I like how they just put number in this one. Okay, rather than frequency. So bar of width 1.5. The area is going to be 1.5 times 5.7. So the area is 8.55. Okay, and we want to try and find the 2 to 3 and the 5 to 10 ones. Cool. So width of 1.5 is a class width of 1, and an area of 5.55 is a frequency of 2, 5, 6, 5. So this one's not as easy to just look at and do in your head. It's a bit harder. I mean, class width 1.5 to frequency, not too bad, times by 1.5 class width to get the frequency. Area, a little bit harder. So let's work it out. Our frequency, 300. So times the area by 300 and you get the frequency. So that's a 1 to 300 ratio for area and frequency. And width to class width is 1.5 ratio, if you want to do it that way. Okay, so if we look at, I'll make this one green. If we look at the green one next, so we've got 2 to 3. So this has a width, class width equals 1. So the width is going to be 1.5 still. And our frequency 1170, if I divide that by 300, so F is 1170, divide that by 300, that gives me my area of 3.9. So I need to work out the height. So height is going to be the area divided by the width, which gives me 2.6. So 2.6 for my height, 1.5 for my area. Okay, now looking at the red one, so we got width is 5 and a frequency is 630. So the width, oh sorry, class width I should say. Yeah, Billy, so far so good. So yeah, class width of 5 is going to be times that by 1.5. Gives me a histogram width of 7.5. And my frequency times that by 300, so divide that by 300 to get my area. So the area needs to be 2.1. Area divided by width gives me 0.28. It does say to one decimal place, so that would be 0.3. Yes. Cool, Billy. Spot on. Well done. Good. Right, let's get out of the way. Hopefully you're all okay with that. That's our area frequency kind of mashup thing there. If there's no questions, I'm going to skip to the last slide. So this is for you guys to do, and we will come back to this first thing or second thing. For probably first thing for you guys on Wednesday. So just quickly talk it through, then you guys can go. So we're going to work out the mean for the data. This is discrete data, so different style to what we've done for the rest of today's lecture. Find the mean, find the median, the quartiles. You can do all of that on the calculator. Then we're trying to find, are there any outliers, and draw a box plot. So kind of summarizing what we've done so far. Good. All right. I believe then we have pretty much finished most of the first half of stats. Wednesday we'll be looking at something called correlation and regression, which is a nice, quick and easy, fun lecture. And yeah, then we're halfway through, which is fantastic. So then we got the really interesting, more difficult stats left. So after Easter, so yeah, on track to finish on time. I will be picking up your mock papers tomorrow after work, so I'll get those marked, and then I might do like a put email results, and we can discuss how you did on Microsoft Teams one-to-one. So you might have a little slot, probably over Easter. We'll spend 5 minutes just looking through your papers. But yeah, thanks for everything so far, guys. Email me if you've got any queries, or complaints, or recommendations to improve